Alrighty, here we are for another Ohio State Test Standard Review. Today we are talking about Standard 8.F.2. This is our next standard in our functions unit area. So let's hop right in. So, question one, we're given a table for liquid 1. We're given a graph for liquid 2. Okay, and it says a scientist recorded the temperatures of two different liquids as they were heated. The results are shown in the table and the graph. And they ask you which statement is true. Let's read our choices. A. Liquid 1 heated at a slower rate than liquid 2 and had a higher starting temperature than liquid 2. B. Liquid 1 heated at a slower rate than liquid 2 and had a lower starting temperature than liquid 2. C. Liquid 1 heated at a faster rate than liquid 2 and had a higher starting temperature than liquid 2. And D. Liquid 1 heated at a faster rate than liquid 2 and had a lower starting temperature than liquid 2. So we're looking at two things. We're looking at rate, which is also known as slope, and we're looking at starting temp, which is also known as your y-intercept. Okay? The easier thing to assess here, right at the start, is the starting temperature, because that's when your time is 0, hence the term starting. Okay? So at time 0, for liquid 1, our temperature is 18. At time 0 for liquid 2, our temperature is at 20. What does that mean? It means that liquid 2 has the higher starting temp. And of course, when you're taking the test, you don't have to actually write all this down. I'm writing it down so that you can kind of see my mindset as I go through it. So if liquid 2 had the higher starting temperature, that means that liquid 1 has the lower. So liquid 1 having the lower eliminates choice A and choice C. And just from looking 2 seconds at the graph in the table, we've eliminated half our choices. So now we got to figure out our rate, our slope. So remember, your slope or your rate is equal to the change in y over the change in x. Okay? So, or we refer to it as rise over run, or we refer to it as m equals y2 minus y1 over x2 over x minus x1, whatever way you want to do it. Okay? The key about a linear equation is that slope is consistent. So when you want to find the slope of the table, you can pick any 2 points. It's a free choice. Okay? So I'm going to pick the points that are the easiest to work with. So for me, that is 0 and 18, with this being our x column, this being our y, and 10, 53. Why? 0 is a great number to work with, and 10 is a great number to work with. 5 is also a good number to work with, but this has a decimal, and I don't like decimals. So I'm going to ignore that. So my change in y, that's 53 minus 18, over my change in x, which is 10 minus 0. 53 minus 18, let's go to our trusty calculator for the first time today. 53 minus 18 is 35. 10 minus 0 is 10. 35 divided by 10 would be 3.5. So this has an M of 3.5, a rate of 3.5. What that means is that for every minute that passes, every 1 minute that passes, the temperature goes up 3.5 degrees. So now we're going to do the same thing for your liquid 2, but this time we're going to use the graph. When you do this, you want to look for a point on the graph that the line is touching a perfect intersection. For example, here. Okay? And also here. This would be 0, 20. And this would be 6, 40. 6, 40. And now we do the same thing. Our change in y, 40 minus 20, over our change in x, 6 minus 0. That gives us 20 over 6. What is 20 divided by 6? It is 3.33. So liquid 2 has a slope of 3.33 repeating. Which one of those is higher? 3.5. So liquid 1 has the faster rate and the lower starting temperature, which means it is choice D. All right, next question. Two linear functions are given. They give you a table of values and they give you an actual just equation. Select the phrase for each blank box to complete the statements that correctly compare the two functions. Okay, so let's talk about linear equations. Linear equations are written in the form of y equals mx plus b, where m is your slope and b is your y-intercept or starting value. Okay? So, function 2 we already know because they wrote it for us very nice and neatly. M is 9. It's the number in front of x. B is 396. It is the constant. All right? So now we have to go up to function 1. Function 1, remember your y-intercept is where x equals 0. They give that to us too. Whoops. It gives that to us as well. At x equals 0, our y is 351. So if we wanted to write this, this would be y equals something x plus 351. So now all we have to do is we have to find our rate of change, our slope. We pick any 2 points. I'm going to pick 0 and 351 and 1 and 364. The reason I picked this, again, 0 is a great number to work with, as is 1. They're very easy. So we do our change in y, 364 minus 351 over our change in x, 1 minus 0. 364 minus 351, well, that's going to work out to be 13 over 1. 13 divided by 1 is just 13. Anything divided by 1 is itself. So this would be y equals 13x plus 351. Your m is 13. Your b is 351. So we're given drop-down choices. The slope of function 1 is less than, greater than, or the same as the slope of function 2. Well, here our slope is 13. Function 2, our slope is 9. So that would mean function 1 is greater than. And you would select greater than. The y-intercept of function 1 is less than, greater than, or the same as the y-intercept of function 2. Function 1 is a y-intercept of 351 and a slope of 396. I'm sorry. Function 2 has a y-intercept of 396. So 396 is bigger than 351. So the y-intercept of function 1 is less than the y-intercept of function 2. And that's your answer. All right. Stephen and Mark are each filling their own bucket with water. Stephen begins with 8 cups of water in his bucket and fills the bucket at a rate of 2 cups per second. Let's stop. Let's write an equation for it. Okay? Begins with, starts with 8 cups of water. That's going to be our y-intercept. Fills the bucket at a rate of 2 cups per second. When you see the word rate, when you see the word per, you're thinking rate of change, you're thinking slope. So your rate of change is 2. So this would be 2x plus 8. The number of cups of water, W, in Mark's bucket after t seconds is represented by the equation W equals 8t plus 1. What statement is true? Okay, so this is Stephen's equation. We're going to put Stephen. This is Mark. So Stephen's slope is 2. That's the number in front of x. His y-intercept is 8. Mark, his slope is 8, because it's the number in front of the t. Y-intercept of 1. Mark begins with more cups of water in his bucket than Stephen. Mark begins with 1. Stephen begins with 8. So, no. Mark begins with the same amount of water as Stephen. Mark begins with 1. Stephen starts with 8. So, no. Mark fills his bucket at a faster rate than Stephen. Mark fills at 8 per second. Stephen at 2 per second. Mark is filling faster than Stephen. So it is C. But last choice, Mark fills his bucket at the same rate as Stephen. 8 is not the same as 2, so that's also gone. Okay? And that's that problem. All right. Charlie and Susan are planning a party for 10 people. Charlie finds a location that charges an initial fee of $20 plus $25 per person. So let's talk about Charlie. Initial fee. Think about what the word initial means. In this case, usually in mathematical cases, it represents a starting value. Okay? So we're going to say your equation here is y equals plus 20 is our starting value. And then $25 per person. Again, we see per, so we think slope, 25x, where x represents the amount of people that you have. Susan finds a location whose rental fee is represented by the equation y equals 15x plus 100, where x is the number of people in attendance and y is the total cost. Select all the statements that are true. So first thing we want to identify, our slope for Charlie is 25. Our y-intercept is 20. For Susan, our slope is 15. Our y-intercept is 100. I'm pulling these straight from the equation. Charlie's location is a cheaper location. All right. So, Charlie's location is a cheaper location. Let's come back to that one. Okay? Susan's location is cheaper for 10 people. So we're going to have to figure out how much it costs for 10 people. So let's do Susan's first. You're going to put in the equation, except you're going to take out x, and you're going to put in 10. So like y equals 15 times 10 plus 100. Put that right into your calculator. You get 250. And you're going to have to do the same for for Charlie, excuse me. Y equals 25 times 10 plus 20. 25 times 10 plus 20. Bam, 270. So Susan's is cheaper for 10 people. Huzzah. The charge for each additional person is greater for Susan's location. Susan's charge per additional person, your rate is 15. Charlie's is 25, so that's wrong. The charge for each additional person is greater for Charlie's location. Again, we just talked about it. Charlie has 25, Susan has 15, so that is true. If the number of people at the party changes to 12, the total cost at each location is the same. So we're going to have to repeat the process. Again, I'm not going to rewrite the equation because it's the same process, except instead of plugging in 10 for x, we're going to plug in 12. That puts Susan's cost at 280, and it puts Charlie's cost at 320. So no, that is incorrect. Okay. So, going back to Charlie's locations or cheaper location. This is a trick answer, and I hate it. Because when you talk about Charlie's location as a cheaper location, you're asking about what context, right? The next choice we're talking about, Susan's location, is cheaper for 10 people. That's easy. We can figure that one out by plugging in 10 for X. When they say Charlie's location is cheaper, is that with 0 people? Is that just the price to rent it? Is that with 20 people, 30 people, 40 people? If they don't give you an amount, I would assume that they're going based off of the starting value. So in this case, Charlie's B is 20, Susan's B is 100. So I would say Charlie's location is cheaper. All right. Brian and Tim ride their bikes at a constant speed and leave from the same location. Brian's ride times are shown in the table. Tim rides faster than Brian. Which graph could represent Tim's bike ride? Okay, so in Brian's bike ride, he gets to his first mile at 8 minutes. Okay, so 1, 8. And you'll notice that our time is our X, our distance is our Y. So all you're going to do, and let me tell you the easiest way to do this, you could find a rate of change. You could find a y-intercept. In both of their cases, the y-intercept would be 0. You could find a rate of change for each of these graphs. What I would do is I would go to each graph and I would go to 8 minutes. And I would pick the graph that has a line that is above 1 at 8 minutes. A is at 1, so that doesn't count. B, look at that, is above 1. C is barely below 1. D is way below 1. So the only way that Tim is riding faster than Brian is if he makes it more than 1 mile in 8 minutes. The only graph where he does that is B. Done. Could you calculate the miles per minute? Absolutely. But there's better ways to do it. A table of values for function A and the graph of function B are shown. Create an equation for a third linear function with a rate of change that is between the rates of change for function A and function B. All right, so we have to find the rate of change for both of these. So remember to do that, we compare our change in Y and our change in X. So for function A, our rate of change, we're going to go with, this is our second point here, and the one above it is our first point. Change in Y, 2.5 minus -2 over your change in X, which is 2 minus -4. Put this into the calculator. 2.5 minus parentheses -2 close parentheses. You get 4.5 over 2 minus parentheses -4. You get 6. Okay, 4.5 divided by 6 is 0.75. That means you have a slope of 0.75 or 3 over 4. If you want to put it in fraction, because normally slopes are done in fractions. So, okay. Now let's find the slope of B. We're going to find 2 points. The y-intercept works perfectly. That's at 0, 3. Our next point, we're looking for one that's on a perfect intersection. Looks like this is our winner right here, 5, 5. So change in Y, 5 to 3, over change in X. I should say this is 3 to 5. Over change in X, 0 to 5. So, that's why I didn't say it like that. 5 minus 0. 5 minus 3 is 2. 5 minus 0 is 5. So this is equal to 2 over 5 or 0.4. So this is a rare situation where you could use a decimal because it makes it easier to fit something between the two. We have a slope here of 0.4. We have a slope here of 0.75. You put any number that is between those two numbers, any number greater than 0.4 and less than 0.5. So let's go with y equals 0.6x. That's it. Done. What else? Y equals 0.5x. That works. You know what doesn't work? Y equals 0.3x because it's less than 0.4. Okay? Just any number that's greater than 0.4 and less than 0.75. Pumps are used to empty water from two tanks, tank P and tank Q. Tank P begins with 65 gallons of water and empties at a rate of 6.5 gallons per minute. The amount of water in tank Q is represented by the equation y equals 63.5 minus 5.25x, where x is the number of minutes. What statement is true? So, there's no real math that has to go into this because they give you all the information you need. You just need to know how to interpret a linear equation. So, they give you the linear equation for tank Q. So, we're focused on tank P. Begins with 65 gallons of water. By now, whenever you hear begin, you should be thinking B in y equals mx plus b. B, begin. So 65 is where we're starting. And empties at a rate of 6.5 gallons per minute. So we see rate, we see per, we think slope. The trick to this question is that we're emptying, which means our slope will be negative because the amount of water in the tank is getting smaller. Okay? So which statement is true? Tank P empties at a faster rate than tank Q and has a lesser starting amount than tank Q. Okay, so this is like the first question. First thing we're going to do. What is the starting value of tank Q? 63.5. What is the starting value of tank P? 65. Tank P has the higher starting value. So choice A, choice C, eliminated. Tank P empties at a faster rate than tank Q and has a greater starting amount than tank Q, or tank P empties at a slower rate. Okay? Your rate for tank Q, it's emptying at 5.25 gallons per minute. Tank P is emptying at 6.5 gallons per minute. Which one is emptying faster? P. So P empties faster and has a greater starting amount. So it's B. All right. Ooh-wee. There's still a lot of questions left on here. Okay, there's only 3 more. All right. Lila and Dwayne each sell tickets to the concert. They start selling the tickets at the same time. Lila starts with 500 tickets and sells at an average rate of 5 per minute. So, equation. Y equals. By this point, starts with 500. That's your B. Sells at an average rate of 5 tickets per minute. So that's going to be 5 times X. But remember, we're selling. Our number of tickets is going down. So that's going to be minus 5X. The number of tickets Dwayne has left after M minutes is represented in the table shown. Okay, that has a starting value, where M equals 0, of 600. And then we got to find the rate. So we pick 2 numbers. And we evaluate our change in Y over our change in X. We're going from 580 to 600. 580 minus 600 over 4 minus 0. And at the end of the day, it doesn't matter what order you put this in. If you want to put the 600 first, you can. But you have to be consistent. So if the 600 goes first, then your 0 has to go first. If your 580 goes first, your 4 has to go first. So you could theoretically write this as 600 minus 580 over 0 minus 4, as long as your points stay together. Okay? Oh my goodness. All right. Let's just get rid of that. All right. 580 minus 600. 580 minus 600 is negative 20. 4 minus 0 is 4. So they are selling at a rate of negative 5. Negative 5. X plus 600. So, which statement is true? Dwayne's average rate of tickets sold per minute is higher than Lila's. Dwayne's is negative 5. Lila's is negative 5. They're the same, which also eliminates choice B. Dwayne begins with more tickets than Lila. Lila starts with 500. Dwayne starts with 600. That is true. And that's your answer. Two plumbers charge an initial fee and an hourly rate. The equation y equals 100 plus 30x models plumber A's fee, where y is the total charge in dollars, and x is the number of hours worked. The table shown represents plumber B's total charge for different numbers of hours. Which statement about the plumbers is true? So we're given the equation for plumber A. Plumber B, okay, will start with actually, we don't know what he's starting with. We don't know what his initial fee is because we only know what he's at after the first hour. So we're going to have to reverse engineer that. Okay? So let's find his rate of change. So we have X and Y. Change in Y, we're going from 105 to 160. So 160 minus 105 over, I got to move this, 2 minus 1. 160 minus 105 is 55. 2 minus 1 is 1. That means his rate of change is 55. For every hour he works, he charges an additional $55. Okay? Now, we can compare this already to what plumber A has. Plumber A's hourly rate is 30. So plumber B has the higher hourly rate. So that means that they're not equal, which eliminates choice A. And if plumber B has the higher one, that means plumber A can't have the higher one. So that eliminates C. So now we're coming down to initial fees. So here's how you do this. Remember what a slope represents. For every increase of 1, for every time X goes up 1, Y goes up 55. So that means it works that way in reverse. For every time X goes down 1, Y goes down 55. So to get to our initial fee, we need to be at 0 hours. So we're going to subtract 1 hour from this first data point. And if X is going down 1, then the Y needs to go down 1. So 105 minus 55 is 50. Oh, should have put it there. So that means that if there was a 0 on here, we would have 0, 50. So now let's compare that. Plumber A, their starting value is 100. Plumber B is 50. That means that plumber A has a greater initial fee. And that's our answer. Whew. All right. That was a bit of a marathon. Longest video we've had so far on one of these standards. So that's going to do it for me. I will be back with another standard. Until then, good luck on your state test.